Hello guys. Welcome back. Thanks for showing interest in the video tutorials on www.logicvoltage.com. This is the fourth tutorial on the video tutorial series on interfacing LCD with STM32F4 board. In this series we are learning how we can interface a LCD and display on it using STM32F4 board. You can check out the website www.logicvoltage.com. In the website, there are many other STM32F4 video tutorials. You can watch them and learn. You can even check out the video store at the website. It has some good tutorial series there with very less price. Lot of peoples are buying it. You can also buy them and learn some very awesome things about embedded programming. You can even get in touch with us also. Just go to Contact Us page and fill up the form, and we will reply. You can even check out the forum also. For any tutorial related query or any technical questions, just create a new topic in an appropriate forum, and write your questions and doubts. And we will reply you there, so that other people can also see the comments, and what discussion is going on. Thanks. Okay, so till now we have written this program. In the last tutorial, we have understood all the concepts of displaying on LCD. We have understood how we will write on LCD memory. We have understood what is meant by memory banks, what memory banks are available to us. We have understood which memory bank we will use. We have understood how we will actually use FSMC peripheral in our Discovery board microcontroller, and write data on LCD memory. And then finally we have understood how we are handling the pixels on the LCD screen and display our characters using the font data. So now in this tutorial we will resume the code writing and complete the program. The first thing we will do here is write the font file. If you remember, I had shown you in the previous tutorial how we will write the font data for each character that we want to display on the LCD. In the previous tutorial, I had shown you font data of a character. In that font data we actually had 16 hexadecimal numbers. So same we will now do for all characters. So basically what we will do here is create a new file, and add a row of 16 hexadecimal numbers for each character that we want to display on LCD. Okay, so let's do that. Let's first add a new file. Let's name this file fontascii.c. Okay, so now our new file is created. Here we will create a two-dimensional array, and store all the font data for each character in that array. Now before that, we have to decide which characters we want to display. And hence we can only display those characters whose font data is present in the font file. Well, in this tutorial, as we are learning, so let's just keep it simple and less characters. Let me show you which characters we will support now in this tutorial series. Okay, so now here you can see that I have opened the ASCII table. In this table we can actually see all the characters along with their ASCII values. Now we can choose to create the font data for all the characters, but we really do not need all characters to learn. Let's just choose only the important characters. If you can see here that we have a decimal column here. In this decimal column, we have the decimal numbers for all the 128 characters in the list. So we will write font data for characters of decimal value from 32 to 126. Hence you can see here that we will support from here. The first one is space. Then next is exclamation mark. Then next is double quote. And similar way continue downwards. We will support all the digits. And then all the characters, both capital letters and small letters. And up to 126 decimal number, which is a tilde sign. Hence its total 95 characters. So basically what I mean is, we will actually write the font data for all these 95 characters. And then we can only display on LCD out of these 95 characters. Okay, so now we have decided which characters we will support for displaying. Let's get back to the program now. Okay, so now, we have to create the font data for all the 95 characters that we have decided just now. So let's start. Let's create a two-dimensional array. As you can see, that size is 95 by 16. Because total 95 characters we will support, and each character will be having 16 hexadecimal numbers as their font data. So we will start writing the font data now. Actually, this will take a lot of time, so to make this quick, I have already written the font data and I will just copy it here. As you can see now, we have a two-dimensional array, and it has all the font data for all 95 characters. You can see that we have started from a spaced character, and then move on one by one, as we have decided from the ASCII list. You might get confused here that how I have written all these font data. Actually, if you have go through with my previous tutorial, then you will be able to understand this. Each character has a 16 hexadecimal numbers as their font data. And how we are writing those hexadecimal numbers, and how exactly they are converted to LCD pixels for display, are also shown in the previous tutorial. If you remember, we have shown an example of a character. So you can see here also that font data for A. This is the same font data as I have shown you in the previous tutorial. So basically the technique is same. If you take any character from here, and manually convert their hexadecimal numbers to 8-bit binary numbers, and try to plot them on the block of pixels on LCD, then you will end up actually displaying that character. So now we have actually created an array where all our font data for total 95 characters are present. Hence we can now print any of these 95 characters on the LCD screen. Okay, you might be wondering, do you have to write all this font data by your own? Don't worry, I will attach this font file with this video on the website www.logicvoltage.com. And when you will be watching this video, you can easily download this file. So no need to write all the code here, by your own. Okay, we have completed writing the font data. But this file is not yet completed. We have to write a function also. We will actually call that function, and pass argument, like for which character we want the font data. And that function will give us the font data of the particular character by using this array. Let's create that function. Okay, so we have created a function here named getASCII-code. In this function, we are passing two parameters. First one is a character pointer, and second one is the character. And then in the function body, we are performing a memory copy function. And that memory copy function is actually copying the font data of the ASCII character, specified in the second parameter. And it's copying the 16 hexadecimal numbers from the two-dimensional array defined above, to the character pointer specified in the first parameter. This character pointer actually points to a memory location, or in other words I can say this will be a character array. Hence we will call this function when we want the font data for any particular character. So what we will do is, we will call this function and pass two arguments. First one is where actually we want the font data to be copied, and second argument is for which character we want the font data. Hence this function will give us the font data. Okay, one more thing to do here. We actually have to define this function above also. Like this. This is just a way of programming. Otherwise we will get compilation error. Okay, so now we are done. This file is now complete. Now we can start configuring and initializing the FSMC peripheral. Let's get back to lcd.c file. Here in this file, we have already defined a function named lcd_pins configuration. This we have written in the second tutorial of this series. In this function, we have configured and initialized the GPIO pins of the microcontroller, and put them in alternate function mode for FSMC peripheral. So now we will configure the FSMC peripheral. And we will write code for configuring the FSMC in this same function. Okay, so let's start. First add a small delay here. This is just to give some time before FSMC start. Then we have to enable the clock for the FSMC. Let's do that. Okay, FSMC peripheral clock is enabled. Then declare the FSMC init structure. And also add one more FSMC structure. This one is for configuring the timing settings on how FSMC will transfer data to LCD memory. So first we will configure the timing settings for FSMC. Let's do that. Okay, here I have written some statements. Actually, these settings depends on the type of memory on which you want the FSMC to write. Each type of memory has different timings requirements, and we have to set here as per the memory. In LCD memory we need almost 15 CPU cycles for address setup time. Hence I have written F in hexadecimal, in address setup time. We need approximately 5 CPU cycles for data setup time, hence I have written 5 in data setup time. Rest we do not need, hence I have written 0. Again, how I come to these number of CPU cycles, that's something depends on memory, and you will get all these information on the memory's datasheet. And if you read FSMC section on the reference manual of the microcontroller datasheet, specifically the section on page number 1533, then you will understand. Okay, in the last, we have set the access mode, A, type. We have actually 4 options here. Mode A, Mode B, Mode C, Mode D. For this LCD we will use Mode A. Okay, so now we have configured the FSMC timings. Next we will configure the FSMC itself. Let's do that. Okay, so here we are setting which part of bank 1 we will use for FSMC. If you remember, in the last tutorial we have discussed that we have 4 banks available in FSMC. And out of those 4 banks, we will use the bank 1. And bank 1 also is even divided in 4 parts. And here we are specifying which part we will use. Actually we can use any part here, because in our case, any of the 4 part can work. So here we are using part 1. Now next thing is, here we are disabling the data multiplexing. We do not need that. Now next is, here we are mentioning the type of memory that we are interfacing with FSMC. In our LCD we have SRAM memory, so we mentioned this. But we have other option also. As you can see we have PSRAM and NOR type memory. But we are using SRAM. Now next is, here we are setting the width of data that we will transfer to LCD memory. If you remember, we have connected 25 wires from Discovery board to LCD, and out of those 25 lines, 16 lines are data lines. Hence we are setting it to 16-bit data lines. Then next is, Okay, so here we are first disabling the burst access mode. We do not need that. Next we are setting the wait signal polarity low, and which is by default low. Hence no change. Next we are setting wrap mode disable. We do not need this on also. And then setting the wait signal, which is also by default as it is. No change. All these configurations are not needed by us, and hence we have kept it by default as it is. If you want, then you can read about them in the reference manual of the microcontroller. But here it is not needed. Now next is here we are enabling the write operation, because we will do write operation on the LCD memory. Now next is again, these are not needed and thus disabled. Now next is here we are setting the timing parameters for the read and write access. If you can see that we are actually passing the FSMC timing structure that we have declared above. So basically we are actually saying the FSMC should use what timings configuration for reading and writing onto the LCD memory. Now next is here we are first initializing the FSMC with all the parameters we have configured above. And then we are enabling the FSMC. Okay, now we are done. We have completely configured the FSMC peripheral now. Now this function is complete. Now next thing we will do is create a new function here in this lcd.c file. Let's do that. We have created a function named LCD_initialization. And in this function we will call the above function, which initializes the FSMC peripheral. Let's do that. Okay, now what we will do is, we will call this LCD_initialization function from the main.c file. Let's do that. And of course we have to include the lcd.c file in the header also. And yes, we have to write the delay function body also, as we have used it in the lcd.c file. Okay, so now we have properly configured the FSMC peripheral. One thing you might be wondering, why we have created a new function named LCD_initialization in the lcd.c file. And then we are calling this function from main.c file. Why not directly call the LCD_pins configuration function from the main.c file? Well, because to initialize the LCD, we are not done with just the FSMC pins configuration, and FSMC itself configuration. There are a lot of other things also that needs to be done, before you can say that LCD is properly initialized. And now from next tutorial, we will write those lines of code in this LCD_initialization function. Okay, so in this tutorial, we have created the font file. We have created the font data for 95 characters. And hence we can display any of those 95 characters in the LCD. Then next we have configured the FSMC peripheral. Now in the next tutorial, we will see how to write data on LCD memory, and how LCD is properly initialized. Okay, once again this is from www.logicvoltage.com. And thanks for watching. Bye.